Indonesia has the biggest archipelago in the world with an area of almost 2 million kilometers square. Located within the world's longest chain of volcanoes called the Ring of Fire, Indonesia is prone to natural disasters. There have been 7 earthquakes with a magnitude of 7 or more since 2004 in various places in the archipelago. Some of them were followed by deadly tsunamis. These earthquakes absolutely costed a lot for the government as they destroyed public facilities, including communication facilities in the affected regions. In addition to that, among the thousands of islands in the Indonesian archipelago, many do not have sufficient communication infrastructure yet, including the outermost and the remote regions and islands, such as small inhabited islands around the town of Ternate in Maluku and the mountainous regions around Merauke in Papua. Therefore, an emergency communication system is urgently needed which can cover these regions when the permanent communication system is broken or damaged or does not exist yet. The student research team of the Institut Teknologi Sepuluh Nopember, or ITS for short, have been working on high-frequency or HF skywave digital communication to realize an emergency communication system that is affordable, easily operated, reliable, and with sufficient data rate. For use in these disaster regions and remote islands, the campaign has evolved for several years and encompassed 3 generations of students from the ITS Electrical Engineering Department, each handling different stages of the system development. The team has developed HF skywave channel measurement and modeling, including an HF system with multi-input, multi-output or MIMO antenna structure to improve the system capacity, as well as HF digital communication system for text and data with single antennas at both sides. A MIMO HF communication system is presently in progress and is expected to be launched next year. The ITS research team also collaborates with teams from other universities such as Universitas Musamus in the small town of Merauke and Universitas Kairun in Ternate. In this video, we will be demonstrating how the HF digital communication system for emergency communication and remote islands work. In this digital communication system, there are several supporting devices including notebooks, dipole antennas, universal software radio peripherals, octoclocks, high power amplifiers, low noise amplifiers, spectrum analyzers, power meters, RG58 cables, RG8 cables, Gigabit Ethernet cable, and LabVIEW software on transmitter and receiver system. To be able to communicate well, besides supporting devices, we also need parameters in digital communication systems such as the modulation, the role of vector value, the alpha value, the filter, the value of the sample per symbol, and protocol which will be used. Then, after all parameters and devices have been properly prepared, communication can be carried out using the high-frequency digital communication system. So how it works? In the transmitter, the message to be sent is written down first in software LabVIEW from notebook, and the settings are made in all the parameters described above. After that, the message will be sent to USRP and then forwarded to octoclock to equalize the time in each region. After that, the message will be forwarded to the HPA by connecting to spectrum analyzer and power meter before being sent to the transmitter antenna. In the receiver antenna system, the message is received and then forwarded to the LNA. After that, it is forwarded to USRP. Software-defined PLL is used for carrier synchronization. Finally, after IQ demodulation, the message will be displayed in the text form on the notebook that has been installed LabVIEW software. Thus, we have that emergency communication that we have been developing for disaster regions and remote island can work well. Thank you. The system has been tested for long-distance communication between Surabaya, Ternate, and Merauke. We expect to have a cheaper version of the system for future implementation.